All right, let's get right into it. Today, we're taking a trip out to the constellation Ursa Major to get a good look at one of the most famous objects in the night sky, Messier 97, though you probably know it as the Owl Nebula. You see, it has a face, and the scientific story of how it got that face, well, it's got a fantastic twist.
I mean, just look at this thing. It's absolutely haunting. Those two dark patches, it's like a pair of eyes staring right back at us from across the cosmos. For decades, astronomers have been scratching their heads, trying to figure out the exact process that carved this incredible shape. And that's the cosmic mystery we're going to unravel today.
So here's our game plan. First, we'll figure out what the Owl Nebula actually is. Then we'll dive into its anatomy based on the very first detailed models. After that, we'll look at the really elegant theory that seemed to explain its face perfectly. But then comes the plot twist, new data that changed, well, everything. And finally, we'll see how this one discovery gave birth to a whole new family of celestial objects. Okay, first things first. What in the world are we actually looking at here? Is it a ghost? Some kind of massive explosion? You know, the truth is just as cool as any of that. It's what's known as a planetary nebula. Now, that name is a little bit confusing. It's a holdover from early astronomy, and it has absolutely nothing to do with planets. Really, it's the final, beautiful breath of a star, kind of like our own sun. The star has puffed off its outer layers into space, leaving a tiny, super hot core behind. And those incredible colors you see, they're not just for show. They're like a chemical fingerprint. That ghostly green that really makes up the owl's face comes from glowing oxygen gas. And the reddish colors you see around the edges, that's a signature of hydrogen. It's the star's own guts, basically, thrown out into space and set ablaze. Okay, so we know what it is. Now let's start peeling back the layers. To understand the face, scientists first had to map out the entire head. So let's take a look at that first detailed model. This diagram here, this is from a really important paper back in 2003, and it was basically our first detailed map of the owl. At first glance, it seems pretty simple, right? You can see the labels for an inner shell, an outer shell, and that central cavity. It was a really clean model that laid out the basic parts. But as you're about to see, the real story is hidden in the details. So based on that model, scientists identified three main layers. You've got that bright inner shell, which is what we actually see as the face. Then, wrapped around that is a rounder, fainter outer shell. And surrounding the whole thing is this massive, wispy halo, shaped almost like a bow wave from a boat as the nebula plows through interstellar space. And this whole thing isn't just floating there. It's an expanding bubble of gas. That inner and outer shell are racing away from the central star at a blistering 40 kilometers per second. To give you some perspective, that's over 89,000 miles per hour. So this isn't some gentle puff. It's a high-speed cosmic explosion happening in slow motion. So we have this multi-layered, rapidly expanding structure. But that still doesn't explain the most famous feature, the eyes. How do you get those? Well, that 2003 model had a beautifully simple and elegant answer. I mean, this was the central puzzle. If a star just puffs off its outer layers, you'd expect a simple sphere, right? Or maybe a bit of an oval. So how in the world do you carve two distinct, eye-like holes right in the middle of it? The theory was basically a three-act play starring stellar winds. First, a slow, early wind puffs out to create that big halo. Then, a much more powerful super wind blasts out and forms the main spherical shell. But it's the third and final act that's the most important. A final, incredibly fast wind erupts from the star's now exposed core. But this wind doesn't go out in all directions. It shoots out in two opposite streams, like a pair of jets. And it acts like a cosmic sandblaster, carving out a hollow, two-lobed or bipolar cavity right through the main shell of gas. And this, right here, is the aha moment. On the left, you see the model, a big shell with that bipolar cavity hollowed out. Now, on the right, you see what happens when we view that 3D structure from our vantage point here on Earth. The two openings of the cavity, they become the two dark eyes. It was perfect. It fit the observations exactly. It was an elegant, totally satisfying solution. And for 15 years, that was the story. Case closed. But the beautiful thing about science is that the case is never really closed. It's always being refined, and sometimes a deeper look completely rewrites the story we thought we knew. Can you imagine? For a decade and a half, this clean, bipolar model was in all the textbooks. It just made perfect sense. But astronomers kept building better instruments, like advanced spectrographs that can map the 3D motion of gas in these things, and in 2018, they pointed them back at the Owl Nebula. And what they found was, well, it wasn't so simple. And this is the moment where everything changed. On the left, you've got that clean, simple simulation based on the 2003 model. Now, look to the right. This is the actual high-resolution data from 2018. The difference is just staggering. See how smooth and empty the eyes look on the left? Now look at the panels on the right. Those show slices of gas moving at different speeds. Instead of two smooth, hollow tunnels, the data revealed this clumpy, jagged, much more complex structure. The elegant solution, it turned out, was just too simple for the messy reality. And here it is, straight from the scientists themselves. The 2018 paper says the cavity has multipolar fingers. So instead of two big tunnels being carved out, imagine multiple smaller jets of gas punching through the shell from different directions. It's like we thought it was carved with a simple chisel, but it was actually made with a whole set of complex tools. So here's the bottom line. The very feature that gives the Owl Nebula its name isn't what we thought it was at all. It's not a simple tunnel we're looking down. It's a complex, messy, multi-fingered structure that just creates the illusion of two simple eyes when you look at it from 2,500 light-years away. And this incredible discovery didn't just change our view of one nebula. Oh no, it cracked open the door to a whole new classification. The owl wasn't just a weirdo anymore. It was the first of its kind. As soon as astronomers knew what to look for, this messy, finger-like inner cavity inside a double shell, they started finding other examples. Suddenly, the Owl Nebula wasn't an anomaly. It was the founding member of a brand new cosmic family. And just like that, a new class was born, Strigiform Nebulae, named from the scientific order for owls. This definition now gives astronomers a whole new category to use when they find these strange and beautiful objects scattered across the sky. And they all share this distinct set of traits. They all have that double shell structure, their central stars are faint and old, and importantly, they have no detectable stellar wind blowing today. That means these complex cavities are probably relics, ghosts, of a more violent phase that happened long ago. The exact story of how they form is still a pretty hot topic. And this is why this story is just so amazing. For years, we thought we had the Owl Nebula all figured out. But by taking a closer look, we uncovered a deeper, more complex truth and found an entire family of similar objects hiding in plain sight. It really makes you wonder, doesn't it? What other cosmic secrets are out there, just waiting for us to look again with fresh eyes?